Hi everyone, welcome to Know Your Chemistry. Today we are going to discuss about nitric oxide. Nitric oxide is a toxic pollutant which is produced by air or automobile exhaust. The vasodilatory effect of nitroglycerin, that is a compound. Nitroglycerin, its vasodilatory effect is due to the release of this nitric oxide. Nitric oxide is also known as EDRF, that is endothelium derived releasing factor or relaxation factor. Coming to the chemistry, nitric oxide is an uncharged molecule. It is having unpaired electron, so therefore it acts as a free radical, and the half-life is 0.1 second. Coming to the synthesis, you can see this diagram. So it is a precursor compound of nitric oxide synthesis is arginine. Arginine in presence of an enzyme NOS, that is the nitric oxide synthase. One NADPH is utilizing here, that is addition of oxygen to form citrulline and a compound known as nitric oxide. Coming to the metabolic fate, nitric oxide can combines with the oxygen and also superoxide anion. Combines with the oxygen to form NO2 that can be normally excreted to the urine. And this nitric oxide combines with the superoxide anion, which in turn results in the peroxynitrite formation, and which is responsible for the lipid peroxidation, rancidity, cell injury, cell death. We have already discussed in lipid chemistry about lipid peroxidation, and you can refer those videos. Then there is a major portion, that is the isoenzymes. Mainly three types of isoenzymes. One is neuronal, second one macrophage, third one is endothelial. Neuronal isoenzyme or the NOS1 or the ornithine nitric oxide synthase, which is cytoplasmic isoenzyme. As the name indicates, it is neuronal, is present in central or peripheral neurons, that is seen in cerebellum and GIT. This neuronal isoenzyme can be activated by calcium, and the gene responsible is located on chromosome number 12. Next, about the macrophage isoenzyme, it is known as nitric oxide synthase 2 or INOS, that is the inducible isoenzyme. That is, it can be induced by cytokines, mainly interleukins 1, TNF alpha, and which results in inflammation. It is also cytoplasmic isoenzyme which is present in macrophages, neutrophils, even the hepatocytes contains this isoenzyme, that is the inducible isoenzyme. And in case of macrophage isoenzyme, calcium cannot activate this isoenzyme. The chromosome number responsible is 17. Next, about the endothelial nitric oxide synthase, that is the NOS3, which is present in endothelium, endocardium, platelets, myocardium, etc., which is present in plasma membrane. And this endothelial nitric oxide synthase can be activated by calcium, and the gene responsible is located on chromosome number 7. So coming to the mechanism of action, one of the major portion of this topic, this nitric oxide synthase enzyme can be activated by acetylcholine. So this acetylcholine attaches with nitric oxide synthase enzyme receptors. It binds with the receptor, which results in the release of IP3 calcium ions, or IP3 calcium channels get opened, ion channels get opened, that results in the activation of nitric oxide synthase. So this activation, that is the nitric oxide synthase activation, which results in the cytokine release, that is mainly TNF alpha. So this cytokine activation results in the guanylate cyclase enzyme activation. So we all know the guanylate cyclase activation results in cyclic GMP production. So once the cyclic GMP is produced or get activated, it results in the further activation of protein kinase. Okay. So protein kinase activation results in either dephosphorylation or phosphorylation. So in case of nitric oxide synthase, protein kinase results in dephosphorylation, that is the dephosphorylation of myosin light chain which results in muscle relaxation. So that results in the vasodilation. So that is the vasodilatory effect of nitric oxide. Coming to the physiological actions, mainly physiological actions on blood vessels, CNS, macrophages, platelets, even in the intestine. So blood vessels mainly potent vasodilator, and also the normal blood pressure can be regulated. In case of CNS, the neuronal isoenzyme is present. In macrophages also macrophage isoenzyme, platelets also isoenzyme will help in the vasodilatory effects. Mainly platelet adhesion can be inhibited. In intestinal system, it has acted as a neurotransmitter. Coming to the application of nitric oxide, that is in disease and treatment. Mainly in case of angina pectoris. Angina pectoris, it is a coronary artery disease. Mainly if we are giving the nitroprusside, so nitroprusside can directly release nitric oxide and results in vasodilation, and also pulmonary hypertension. Then erectile functions, that is neurologically related erectile functions can be cleared. And also shock, that is neuronal isoenzyme, which helps in the shock regulation. Then nitric oxide synthase enhances, that is mainly S-nitroglutathione and N-acetylcholine. And the nitric oxide antagonists are N-monomethyl arginine and N-monomethyl arginine and asymmetrical dimethyl arginine. These two compounds act opposite, that is antagonistic effect on nitric oxide. Thank you. So please like, share, comment and subscribe my channel. Thank you. Thank you so much.